Hello and welcome. I am your host and speaker Anubhav Kumar Gupta. I am Associate Data Engineer at Infometry. Thank you for taking the time to join us today. In today's webinar, I will be talking about Delta Lake and how it is useful for data engineers. Feel free to drop questions on the topic or share your struggle and experiences during this live session. We will answer your queries through chat. Let's start this session. This session is organized by Infometry. We are a pure play data analytics company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inspection back in 2010, and since then we have been offering domain-specific analytics solutions for high-tech, energy, life science, retail, manufacturing, and finance customers. Being a analytics software services and software provider, we focus on delivering predictive and prescriptive analytics solution, cloud data warehouse implementation, data governance, enterprise service bus, microservices based integration solution, big data, cloud DevOps, Salesforce CRM, and product engineering and etc. Infometry has been engineering and consulting service partner for companies like Snowflake, Google Cloud, Informatica, MuleSoft, Databricks, Fivetran, AWS, Tableau, Adaptive Insight, Microsoft Azure, and Matillion and etc. Moreover, Infometry has developed 20 plus Informatica cloud connectors and Snowflake native applications with pre-built connectivity to NetSuite, Salesforce, and Marketo, enabling real-time analytics across Snowflake, Google BigQuery, Amazon Redshift, Databricks, and Azure Synapse. One mention under Blue Box are developed and owned by us, and the rest all are developed by us only for organizations like Informatica, SAP, Caladius, and etc. We have developed state-of-the-art analytics solution in Infofiscus, which can be hooked to any on-premises or cloud CRM, ERP, or planning application. Infofiscus is 100% cloud-based pre-built analytics software developed using open architecture. Infofiscus comes in three different flavors: finance, supply chain, and sales, and market analytics. We delighted to announce the launch of next generation Infofiscus Snowflake native application, featuring pre-built connectivity to NetSuite, Salesforce, Marketo, and more. This application enables seamless integration and real-time analytics. That's our quick introduction, and let us move to our today agenda. Let me start by talking about data warehouse. Earlier, companies mainly used data warehouse for BI reports and dashboards. They were designed for structured data like sales, finance, and customer records. But over time, businesses started generating new types of data like videos, audio files, test logs, sensor data, social media data. Traditional data warehouses are not good at handling this kind of data. Also, they don't support machine learning properly. Streaming data is difficult to manage. They are mostly closed system and expensive. So because of this problem, companies started storing most of their data to data lakes and storage system, that is cloud. In this diagram, we can see data coming from different sources, going through ETL, and then going to the data warehouse for reporting. Now let us talk about data lake. Data lakes are designed to store all type of data. It can be structure, unstructured, semi-structured. They are very useful for data science people, machine learning, big data analytics. But data lake also have many problems. First, BI tools do not work very well directly on data lakes. Second, setting up and managing data lakes is complex. Third, performance is usually slow. And the biggest problem is data swap. When data is stored without proper structure, rules, and quality checks, the lake becomes dirty and unreliable. Then no one trusts the data. Because of this, most companies use both data warehouse, data lake. This creates a complex system and increase cost and maintenance as well. Now the big question is how can we get the benefit of both systems? From data warehouse, we want fast query, reliable reporting, structured data. And from data lake, we want flexibility, low cost, support of AI and ML. But managing both together is difficult. So companies need one platform that combines reliability of warehouse, flexibility of lakes. This problem leads us to solution called the Delta Lake. So here comes to Delta Lake. Delta Lake is an open source storage layer built on the top of data lakes. It brings data warehouse features into data lakes. So we can say Delta Lake equals to data lake plus reliability plus performance. Some key benefits are it supports transaction, it supports ACID transaction like databases, it supports faster processing with indexing and optimization, query become faster, it supports data governance, we can control who can access which data. So now instead of choosing between data lake and warehouse, we can use delta lake and get both. This slide talks about data quality and reliability. Delta Lake provides a single source of truth. That means everyone in the company sees the same correct data. The main features are ACID transactions, like ACID means atomicity, consistency, isolation, and durability. This ensures that data is always correct, even if failure happens. Second is schema enforcement. If wrong data came, Delta Lake can block it. This avoids bad data. Third is schema evolution and enforcement. If new columns come, Delta Lake can adapt easily automatically. Fourth one is merge, update and delete. We can modify existing data. This was very hard in normal data lakes. Fifth is time travel. We can go back to the old version of data. So Delta Lake makes the data reliability and trustworthy. Now let us talk about performance. Normally data lakes are slow, but Delta lakes improve speed using file compensation, indexing, caching, Z ordering, data skipping, and liquid clustering. Because of this, queries can much faster. Queries can run much faster. This slide show that ETL workload can be up to 48 times faster. Delta engine also gives better price performance. So companies get high speed, low cost, high reliability. This is very useful for large scale data pipelines. This is the one most powerful feature of Delta Lake, that is time travel and versioning. Time travel means we can see how data looked in the past. For example, at 9 a.m. that is considered as the version 0, that is initial load. At 10:30 that is version 1. At 12 p.m. that is version 2. At 2:30 that is current version. So every update creates a new version. We can query old data anytime. Use cases. First one is data recovery. If data is deleted by mistake, we can restore it. Second is auditing. We can check who changes what and when. Third is A/B testing. Compare old and new data. Fourth is debugging. Find where the error started. And fifth is reproducibility. Data scientists can run experiments again. Now comes to the security part, security and compliance. Security is very important in companies. Delta Lake helps in data security and compliance. It supports access control, role-based permissions, audit logs. So only authorized users can see sensitive data. It also helps in following laws like CDPR, CGPA. For example, if customer asks to delete data, Delta Lake can remove it properly and track changes. This makes data system legally safe and trustworthy. And let's go for the demo and we can see there how it is useful for the data engineer's perspective. So now that we have understood the concept and features of Delta Lake, let me show you a practical demo. Now let's go to the Databricks platform and let's see the illustration for the same. In this demo, I will show you how to create a Delta table, how updates create versions, how Delta maintains history, and how we can perform time travel. Let's move step by step. Starting with the PySpark, here I'm writing with a simple PySpark in simple PySpark environment. First, I imported the required function from PySpark.sql.function. This is important because we will use operation like with column, when condition, sorting, and transformation. So this is just basic setup. Before we begin working with the data, we need to read data. So I'm reading data from CSV file. You can see format is CSV, header is true, and info schema is true. Info schema means Spark will automatically detect the data types corresponding to the column. The dataset contains, you can see here, branch ID, dealer ID, model ID, revenue, unit source, data ID, etc. This is a simple sales data which I loaded into the Databricks. Right now, this is just a normal Spark data frame, not a delta table. Here, now this is the important step. Here I converted the delta CSV data into a delta format using write.format.delta. You can see here write.format.delta. These simple step transform normal Parquet-based storage into a delta table. Behind the scene, delta will create a special folder called underscore delta underscore log. This folder maintains version history, whatever the changes which we are performing like DDL operation or DML operation, transaction log, and all those metadata. So now our data lake has transaction capabilities. Now here I am reading the delta table using spark.read.format and the parenthesis delta. This confirms that the table is now a delta table. The data looks the same, but internally it supports AC transaction, time travel, and version control. Now here I am sorting the data. I am performing some simple transformation. I sort the data based on units sold in descending order. This is just to show how delta table behave exactly like normal Spark data frame. So from user perspective, there is no such difference in how we query the data, but internally delta ensure consistency and performance. Adding a new column, you can see here I'm adding a new column called as a profit margin. Profit margin is equals to revenue divided by unit sold. This so that we can easily perform and enrich the data. We can perform any type of DML operation. Again, no complexity. Delta behaves like a normal data frame. But now the powerful part, updates, sorting by revenue. Here you can see. Again, this is just a normal analytics query. Now let us simulate a real world scenario. Imagine we need to correct some data, updating BR 1540. And here I updated the unit sold and branch with the same which I told. Suppose earlier value was wrong and we corrected it to 5. After updating, I save again in delta format. Important thing, even though I use override method, delta does not delete history. It creates a new version of the transaction log with the file name something called 00.json. This is the power of delta lake. Another update, if I will perform any update in BR1555 and save it, now I perform this time for the branch BR1555. Again after updating, I overwrite and save. Now we have multiple versions created. Let us see how Delta tracks this. Delta tracks this. Here I am using, this is the most powerful command that describes history. It shows all those things like version name, timestamp, user ID, operational perform, what are the operation which is having a parameters, and what time we perform those actions, like that. We can see multiple writes operation. Each update created a new version. This is automatic. When we did not manually maintain version, Delta did everything for us. Here I am reading the version number 4, as I told in the critical part, like we can perform time travel. So here you can see version as of 4. So I am time traveling. Give me a time. Give me the table exactly as it is. It was in version 4. This is called time travel. Even after multiple updates, I can go back and see old data which I deleted mistakenly. This is extremely useful for auditing, debugging, and data discovery. Here we can do the same using timestamp method. We can also travel using timestamp as of. This means give me the data as it existed at the exact time. This helps when you know when the issue happened, but not the version number. This makes debugging very easy. Here I am again writing the describe details. Now I run describe details. These show format as a delta and table ID and location and all those metadata. This confirms that this is a delta table. This is also known as internal configuration detail. This helps in governance and tracking. Let me show you here all the DML operation which I perform. Let me show you the delta underscore log folder which I already talked about. As you can see here, it is sales underscore src, sales underscore sync. Inside that volume, I created my all those things inside this data, which is here. You can see whatever the delta underscore log, whatever the transaction you will perform with that particular transaction, whatever the right you will write with that particular transaction, it will create one .json file. You can see 000. This is first time which I am loading the data. The second one, whatever the operation I perform. The third DML operation which I perform. The fourth operation which I perform. Through this only we can track, we can go back and we can revert to the previous version. And even for each and every things which are not which was not available in the data Alex, that is available here. Here you can see one more file, that is .crc, that is cyclic redundancy check. That is mainly useful to see whether the data from the source to sink went well or not, and to find anything wrong. So you can see my data was originally in the form of CSV, but I converted into a Parquet. But originally the data will be in the Parquet format only. The transaction will be in the form of JSON file. So we can go and we can make some changes. Delta doesn't support data in a new format. It stores data in Parquet only, and it uses delta log to manage versions. So delta lake is equals to Parquet file plus transaction log, we can say. This is the simple architecture. So final closing for the demo I am saying. This is the demo we saw how to convert CSV to delta, how update creates new version, how to check history, how to perform time travel, and how delta maintain logs internally. This clearly shows how delta lake brings and how it is powerful and like reliability and the data lakes. Now let's go back to our slide. To summarize this, earlier we had data warehouse that is reliable but limited, data lakes flexible but unreliable. Delta lake combines both. It gives reliable data, fast performance, easy updates, version control, strong security, and lower cost. For data engineers, data scientists, and analytics, Delta Lake is a very powerful tool. If you are building modern data pipeline, Delta Lake is definitely worth learning and using. Thank you for your time. I'm happy to take your questions.
Yeah, thank you so much, Anubhav, for this amazing session on Data Lake. I would request everyone to please ask their questions.
Hi, Anubhav. So Shreyas this side.
Ashish.
So my question is like, what is schema enforcement and schema evaluation in context of Delta Lake?
So, schema enforcement is nothing but data must match the table schema, otherwise write will fail. Suppose let us take an example. ID is equals to int and name is equals to string. If you try ID is equals to int and name is equals to string, and again if you are adding a new column that is age is equals to int, it will reject it. Why? Because it prevents the garbage or bad data entering into your system. And you ask one another question: what is schema evolution? So it is nothing but it allows schema to changes with the time, like adding new column in the future. So for this, we can run a simple query, that is alter table, add column, whatever the column which you want with the means respective data type. Now the new data with the respective column will be added. So in one liner, you can say schema enforcement protect data and schema evolution gives you flexibility.
Yeah, I got it. Like, thank you, Anubhav.
Yeah, thank you.
Hey Anubhav,
Yeah,
I
yes,
have a
yes.
question like how Delta Lake is different from Parquet files.
So basically, the Parquet file is nothing but it is a file format. But Delta Lake is not a file format. It is a storage layer on the top of Parquet. You can assume it like a metadata layer. And this Parquet doesn't support this ACID property, but this Delta Lake it supports. Schema enforcement is not supported by Parquet, but it's supported by Delta Lake. So with Shreyas has asked schema evolution and enforcement. So these all things are not sort of supported by Parquet file, but it is supported inside this Delta Lake. This is how it is different from Delta Lake. This Parquet from Delta Lake. I think I've given you the answer.
Okay, okay, thank you.
Yeah.
Yep. Anyone else? Poonam, Padma, anyone else who wants to ask the question, please let me know. Anubhav, I also have a question.
Yeah,
Like,
yeah. You can.
what problems does Delta Lake solve?
So before Data Lake was there. Like Parquet file on S3 ADLS GCS bucket we were storing. But we had an issue that it doesn't support asset transaction. It doesn't have schema control. It doesn't have. I mean, it was having a difficulties in update and delete, and it was not having a versioning. The concurrency issue also was there because multiple jobs were overwriting the data. So this Delta Lex is solving all those problems which I mentioned, which I mentioned to the Siraj and Ibrahim as well. Like it supports ACID transaction, it supports schema evolution, it supports schema enforcement and time travel and upset for the beta performance.
Got it. Yep, understood. Thank you so much for the session, and thank you everyone for joining the webinar on Delta Lake. I hope it was insightful, and yep, that's it for the day. Thank you so much for joining.
Yeah, thank you everyone. Thank you, Siraj and Ibrahim.